Hello everyone, welcome to Build with Jaswinder. As part of this video series, today we will be building the logic to solve this LeetCode problem 3 sum. So what's the problem? In this we are given an integer array nums. We have to return all the triplets nums I, nums j, nums k such that these three indexes are different and the sum of all the elements at these indexes is equal to 0. We have to note that the solution set must not contain duplicate triplets. I'll show you what does this duplicate triplets means. So let's say we are given this example. In this example, what will be the what will be the triplets? Basically three elements that sum to 0. Let's say if I take this minus 1, this 0 and this 1, what will be the sum? Again, this minus 1, this 0, this 1. The sum would be 0. So this is one of the triplets. Is it a valid? Yeah, it's a valid triplet. What could be the another? I'll just write down all these here. So the output would be minus 1, 0, 1 because if I sum all these elements, so the answer would be 0. There can be another case. What happens if I take this minus 1 and this 2? The sum again would be 0 in this case. Okay. Now, can I take this triplet too? Let me just write down. See. So here we took this minus 1, this 0 and this 1. Can I take this 0, this 0, this 1 and this minus 1? Can I take it? Let me just write down 0, 1, minus 1. Can I take this triplet as my valid triplet? Is this valid? So here comes that interesting part. The solution set must not contain duplicate triplets. This and this, they are similar. How they are similar? If you notice, here we have minus 1, here we have minus 1, here we have 0, here we have 0, here we have 1, here we have 1. So all the elements that are in this set that are in this list are also in this list. So we have to include only one of them in my output. So let's say I added this, so this will not be part of my output. So this is what it means duplicate triplets. So now you might be thinking that we could just iterate through all the triplets and yeah, that's one of the valid solutions, but the time complexity would be, I think, much greater. So it will not get passed on the lead code. But still, we'll just get to that optimized version after we just come up with the brute force. So I'll just quickly write down. So what we can do is we just generate all the triplets and see if they sum to the given target or not. Okay. And the target is basically 0. So let's just rephrase. So we just have to find three elements whose sum is equal to 0. So we will have one index, one loop that goes from 0 to n minus 1, another loop from 0 to n minus 1, another loop from k0 to n minus 1, and then we'll just check if nums I, I'll just write n in place of nums so that it's much easy for me. I'll just check if these three sum to 0. If it, then it means this is my valid triplet. Okay. But before I move on, let's try to solve this. Let's try to see this. These three indexes has to be different. Will it be different in this case if my I starts from 0, J0, K0? No. When I starts from 0, J can be 0, K can be 0 too. And then this triplet might not be a valid triplet as those indexes might be same. So how can I fix it? I can just iterate J from I plus 1 to n minus 1, and I can just iterate K from J plus 1 to n minus 1. Now, what happens here is when my I is 0, J will start from 1 and K will start from 2. So this I, J and K will never be the same. So we have solved this situation where all these three indexes has to be different. Now we have to take care of this. The solution set must not contain duplicate triplets because here, let's say in the given problem, if you notice, there was this element given to us and then there was another triplet which was, if I go by here, 0, 1 and minus 1. 0, 1, and minus 1. So here, when I see this, ideally this should not get added to my answer, because although this is a triplet whose sum is 0, but this is not a valid triplet because this is ideally similar to this one. How can I achieve that? It's pretty easy. I could just have a list. I could just create a list here. I'll just create a list of integers. Okay. I'll just add all these elements uh, in my list. So this is arrays dot as list. I'll just add all the elements here. Nums I, nums j, and nums k. And then what I'll do is I'll just sort this list. You might be getting an idea what I'm trying to do here is. Then initially what I'll have is I'll have, rather than a list, I'll just have a set of list. And what will happen is when I sort this list, this will get transformed to minus 1, 0, 1. So this is already sorted. This will get transformed to minus 1, 0, and 1. And here I'll be just adding this list to my set. So when it sees this, it will just add this to my answer. And when it sees this, it will not be get added because this list will be a duplicate. Okay, so we were required to solve these two use cases, I, J, and K. All of these are three indexes are different, and the solution must not contain duplicate triplets. So when I did traversal in this way, these three indexes will always be different, and I used set to avoid duplicates. If you notice, what will be the time complexity of this solution? I'm just running three loops, so the time complexity would be O of n cube, and the space complexity would be, here I'm just using a set, and at max how many elements can be there in my set. All of the elements can be in my set, right? So space complexity would be O of n. And what were the constraints given to us in the problem? If you notice, nums dot length is less than equal to 3000 and greater than 3. So this will comes down to 3000 cube. So what will be it? I think it will be 27 into 10 raised to power 9. So this will give me TLE on the Leetcode, even if I try to sum it. As a rule of thumb, my complexity has to be less than equal to 10 raised to power 5 or 6. Only then it passes. So can we do better than this? Let's try to think of a better solution. I'll just write down the same example here, and we'll just try to see if we can think of a better solution. So when I fix this element as my first element, so let's say I fix my first element as minus 1, then what should I do? My required triplet is such that nums I plus nums j plus nums k, they should all three sum to the given 0, right? So if I fix my first element as minus 1, so what should be the sum of other two elements? Can I say that the sum of the other two elements has to be negative 0 minus nums k, or just negative of my nums I? So if I fixed my first element, then I just have to find the sum of two elements such that the sum is minus nums I. So my target will be minus nums I, and I have to find two such elements. So have you seen this problem before? Can I say this is similar to two sum problem? So when I fix my first element as minus 1, all I have to do is basically I just have to find two elements whose sum is 1, so that this minus 1 and those two elements 1, they give me 0. So minus 1, what's the target here if I fix my first element as minus 1? the target would be minus nums I, which will be 1. So I have to find two elements from the remaining elements such that their sum is 1, which I can get from here, definitely. So this boils down to two sum problem. Now, how to solve that two sum problem if you remember? We just have to sort the array first. Okay, so I'll just use the same example. The first thing that we need to do to solve two sum problem is we have to sort the array. If you haven't watched my that video, I'll just post that link in the description. You can check out that too. So the first step is to sort the array. I am just sorting the array. So what happens now is I'll just fix my first index here, and then from the remaining elements, which is this to this, I have to find two such elements such that their sum is equal to negative of this, which is 1 out of these remaining elements. So this is two sum. Okay. So what we'll do is we'll just use a two pointer technique. What is that? I'll just show you. So when my I is 0 at this index, I'll just set my j to I plus 1, which is first index, and k to the end of the nums length, which is this index. So I'll just writing the indexes here. So I'll just set my k to 4. So now see, I know my when my I is 0, my target is minus nums I, which is 1. So now using these two pointers j and k, I have to find such elements so that their sum is 1. Okay. Now what see, this 2 plus this minus 1 is 1, which is equal to my target, which is just what is required, right? So it means I have found a valid triplet using this I, this j, this k. I'll just add it to my answer. So let's say this is my answer list. So I'll just add minus 1 and 2, right? Now what happens when I have found the answer? I'll just increment my j to the next index because there might be some other triplets too which can be formed using this as my first index by fixing this as my first index, right? So I'll just increment my j. If I found the answer, I'll just increment my j to 2. Now my j is here. I'll just remove this one. Okay. Now target is 1 and my sum is 2 plus 0, which is 2, which is higher than the target. Now if my sum is higher than the target, it means I have to decrease my sum. How can I decrease my sum? In two pointer approach, I just have to move my k index one step to the left. So now the k will not be here. K will comes down to this index. I'll decrease my k to 3. Now what happens is again I do the plus of nums I, nums j, nums k, which is 0 plus 1, which is 1, which is the required sum. So what does this mean? This means when I fix my I to this index, j to this and k to this, it's a valid triplet. So again, I can add that to my answer here. Okay. So now what happens of those two problems that we see before? These two, that nums, these indexes has to be different and the solution must not contain duplicate triplets. In this case also, if you notice, my triplets will be having a different indexes all the time because I'll be making sure when I'm incrementing or decrementing, I is not equal to j and j is not equal to k. Okay. And how I can make sure that triplets, they are unique, like they are not duplicate. If you notice here, when I fixed when I fixed the I as this as the first index, and I calculated using two pointer approach that if there is any two elements such that sum to the given target 1, okay, I added this to my answer. Then I need to fix this as my first index, right? and then this, and then this. Okay, obviously these two doesn't make sense. If I fix this as my first index, then there will be no two elements. But you get the approach, right? I'll be fixing this element as my first index, then this. Do I need to fix this as an element as my first index? If I fix this element as my first index, this will be minus 1, the target will be again 1. So you see, I'll be doing the same repetition here, that if my this element is my first index, I have to find two elements from my nums array such that their sum is 1, which is looks like a duplicate, right? If I have already checked all the triplets by fixing my first element as minus 1, then there is no need to check it again, right? To fix again my first element as minus 1. So I have to skip this minus 1. So basically, I'll be just uh, ignoring those elements for which I have already calculated the answer. So when the first element comes to this position, I'll just skip all the iterations for this one by checking if this is equal to my previous element, as this we already sorted this array. So we'll not have to check by fixing this element as my first element. Okay. So I think you get an idea. I'll be just writing the pseudo code so that if it's not understood, we can see. So the first step is we will just sort the array. Okay. So we'll be just sorting the array, and we'll have one list, let's say list integer, which is our answer variable, which will be returning. So this is a list, and we'll just have first element will have a loop just to calculate the first element. So our I goes from 0 to n minus 1. This is to fix my first element. If you remember, I told you that we will be skipping all those iterations for which we have already seen the first element. So if I is not equal to 0, and if this nums I is equal to the previous element, so what does it mean? It means I have already fixed this first element. So let's skip it. Let's skip it. And if not, then we just have to use a two pointer approach. Okay, by just having two pointers j and k. So my j will be at I plus 1 and k would be at the end of my given array. So this is a standard two pointer approach which I'm just using here while j is less than k. If you haven't watched this video, you can again check it on my YouTube. I have added this, and what happens is now this is simple. So I will be calculating a target here, right? I'll just add one line here. Uh, Target is equal to minus nums I. Okay. Now there could be three cases. What? If my num j plus num k is equal to the target, so what does this mean? It means I have found a valid triplet, right? I could just add this triplet to my answer. So I'll just create one list out of these three elements, which is ni, nj, and nk. So this is n is nothing but this is the nums array. And now what should I do here? So see, this is an interesting part. This is just to avoid the duplicates. Now when we fixed our first index as I and second index at j, now we know our array is sorted. So let's say here the first element, I'm just assuming this is my first index, and when j is at this index and k is at this index, we had a valid triplet. So if this j is also, if this j here is also equal to, let's say this the elements at this index is 4 and this index also is 4. So if this is the first index and this is the second index, do we need to check for this index also? We know that I is fixed, j is 4. Now again, if we have the same j 4, then k will always will be the same, right? We will have a duplicate. So we also need to skip this part here. If you don't get this, just try to run it for some examples. You will see that when I fix my first index as I, second index as j, I don't have to calculate the same elements for j also. So let's say I'll just give you a quick example. So I here is minus 4, okay, and k here is 8, okay. Now what will be the I here? I will be minus 2, j will be minus 2, and the other element will be minus 2, okay. So this is, so when I is this, j is this, and k is this, uh, so I'll just write 6 here, sorry. So minus 4 minus 2 is minus 6, and plus 6 is 6, so this is 0. So when I checked for this minus 2 as being the second element, then I don't have to check for this j also, right? Because this will give me minus 4 minus 2 minus 6 and 6, the same answer, right? So I have to skip this 2. So what I'll do here is, basically I'll just have a loop here. So I'll just store in the val what's currently in my j variable, okay. I'll just have a loop that while my j is less than k, and if my nums j is equal to the val, then just skip the j. Okay, now the other case is if nums j plus nums k is not equal to the target. So let's say if nums j plus nums k is less than the target, what happens in that case? If my sum is less than the target, it means I have to increase my sum. How can I increase my sum? I just have to move j to the right. And if the third case, if nums j plus k is greater than the target, it means I have to decrement my sum. How can I decrement my sum is I have to move k to the left. And in the end, I just have to return answer, which is this list as my answer. And what will be the time complexity of this solution? See, what will be the time complexity of this solution? We are just running one loop here. Okay. Before that, we just sorted. So this is n log n. Then there is another loop for n. So the time complexity would be, I'll just write down n log n plus, there is a loop n. For each loop, we are running a two pointer approach, which takes of n time. So overall time complexity would be of n square, and the space complexity would be of 1, as I'm not using any extra space except this answer. And generally, the output space that we use, we don't include it in the space complexity. Now I'll just show you the same approach being written down on the Leetcode. Okay, I'll be just using the same approach. Let me share my screen. I hope you guys can see my screen. So I'll be just running the same approach. So the first step is we need to sort the array. Then we have to initialize our answer list. So I'm just initializing that list. Then we have to fix the first element. So the first element goes from 0 all the way to the end. And I'll have to calculate my target, which is nums I. I can say 0 minus nums I, but it eventually comes down to minus I. There is a one check here. If I is not equal to 0 and my nums I is equal to nums I minus 1, I have to continue. I just have to skip the first element because I have already calculated the values or the triplets using this as my first element. So now there will be two pointers, j equal to I plus 1 and k equal to the last index. So this is a standard while j is less than k. Now there will be two conditions here. Let me check my layout. So there will be two cases here. If nums j, three cases, sorry. If nums j plus nums k is equal to my target, then this means this is a valid triplet. So I'll just add this to my answer. So nums I, nums j, nums k is the valid triplet. If you remember, I have to skip all the iterations for this j also. So I'll store whatever the value is stored. I'll check if while j is less than k and nums j is equal to the val, then I'll just skip all the j's. If you remember what could be the other case, this nums j plus nums k is less than my target. So if this is less than the target, it means I have to increase my sum. How can I increase my sum? I have to increment the j pointer. Else, I have to increase my k pointer. And in the end, I'll just return my answer. Let me just try to run it to see what does it says. So it says bad operand types for binary operator. So while j is less than k and so here it should be double equal to. So basic test cases passes. Let me try to submit. So it got submitted. Hopefully you guys understood the problem and the solution. If so, then please subscribe to my YouTube channel. It will help me in motivating and I'll just post more such videos. Thank you so much, guys.